morning. I am K. Prakash, working as an assistant professor in the Department of Mechanical Engineering. Today we are going to discuss a case study in the heat engines. So what is the case study today is, so we know that in heat engines it works between a hot source and a cold source. Okay. So here there is an hot source and there is a cold sink. Hot source and then cold sink. So here this is an heat engine. So the operating temperature is 560 Kelvin and 280 Kelvin. So this is an operating temperature between this. So we are taking the temperature as T1 is 560 and T2 as 280 Kelvin. Here now the heat supplied is taken as 1120 kilojoules per second. So this is the heat supplied in the condition, and now we are taking three cases. So what are the three cases is, so initially we are taking 900 kilojoules of heat rejected, and then we are going for 560 kilojoules of heat rejected, and the third condition is 108 kilojoules of heat rejected. So here, based on the three conditions, we have to find whether it is reversible, irreversible, or not possible heat engines. So this is our case study today. So everyone are clear that what is a heat engine is, when a heat is supplied, some amount of heat is converted into work done and some amount of heat is rejected. So this heat engine operates between two different temperatures. So here in our case study today, the heat supplied is constant for all the three conditions. The heat supplied to us is constant for all the three conditions, but the heat rejection is varying in the three conditions. So based on these conditions, whether we have to find out whether it is a reversible heat engine or an irreversible heat engine, or it is not a possible heat engine. So these three are the conditions we have to find. So coming to this, here we are taking the heat supplied as Qs and heat rejected as QR1 and QR2 and QR3. So now coming to our Carnot cycle. Okay. So what is the efficiency of Carnot cycle? We will go for a solution here. So efficiency of Carnot cycle is temperature of the hot source minus temperature of the hot source. Okay. So there is an hot source, higher temperature, lower temperature, and temperature of the higher temperature. So here, if you take the temperature of the higher source, it is given as 560 Kelvin, whereas the temperature of the cold sink or the lower source is given as 280. So here 560 minus 280 divided by 560. So if we solve this, we are getting the efficiency is 50%. So the maximum efficiency is 50% in the case of Carnot cycle. So this is the maximum efficiency which we can get. So now we are coming to our condition 1. So what is our case 1? So in the case 1, heat supplied is always 1120, whereas the heat rejected is 900 kilojoules. For this condition, we are finding what is the possible efficiency. So here what is the efficiency? efficiency is QS minus QR divided by QS. So here 1120 minus, what is the heat rejected is 900 divided by 1000. So if we take the efficiency, so if we solve this 1120 minus 900 divided by 1120, so the answer may be around 19.6%. Okay, this is correct. If you take 900, it is 220. Okay, so we are getting 220 by 1120. Is this percentage is correct? 19.6% is the efficiency. But what is the maximum efficiency of Carnot cycle is, we have found out is 50%. But in our case 1, the efficiency is 19.6%. So this efficiency in the case 1 is lesser than the maximum efficiency. So this is a possible, so this is a possible reversible change. So because the maximum efficiency is 50%, but according to our case 1, the possible efficiency, maximum efficiency is 19.6. So it satisfies the condition. So this is a possible reversible heat engine. Coming to our case 2. Coming to our case 2. Here we find the efficiency. In the case 2, the same formula is used. Here the heat supplied is same, 1120 minus, here in the second condition the heat rejected is 560. Heat rejected is 560. So here 1120. Now if you solve this, the efficiency is 50%. Okay. So now if you compare the efficiency of the case 2 with the efficiency of the Carnot cycle maximum efficiency, what is the condition is both the efficiency are same. So here the efficiency in the second condition, efficiency of second condition is equal to maximum efficiency. So based on our previous studies, what we have studied is always the efficiency of the irreversible heat engines are equal to the maximum efficiency. So here both it is 50%. Therefore, this is a possible irreversible heat engine. Okay. Now we have solved these two cases and we are coming to the third condition. Coming to the third conditions. Okay. So what is the third condition is the same heat supplied is same, but whereas the heat rejected is only 108 kilojoules. Now let us see what happens in the third conditions. So the formula is same. Okay, and then here the formula is QS minus QR divided by QS. Okay, so now what happens here is QS is 1120 minus 108 divided by 1120. So what will be the answer here? So what will be the efficiency here? So it is around 90%. Okay, so the efficiency, if we solve this, it is around 90%. But now we compare the condition of the case 3 with our maximum efficiency. What is happening here? So the efficiency in the third case is, when compared, is greater than the maximum efficiency. Okay. So here what is the efficiency in third case is 90%, which is greater than the 50%. So always no heat engine or any heat engines cannot be or cannot produce efficiency more than the maximum efficiency. So here this condition is not possible. So this is not possible heat engine. Okay, this is not a possible heat engine. Why means because the efficiency is according to the condition, the maximum efficiency is only 50%. But in our case 3, the efficiency we have got is 90%. So this is not possible. So this is a case study on the heat engines. So we will summarize this. So here, what is the case study we have discussed is, we have taken the heat supplied and the operating temperatures between the hot source and the cold source, and we have taken 3 different heat rejection based on 900 kilojoules, 560 and 108 heat rejections. So based on these 2 conditions, we are finding that it is reversible or irreversible or not possible heat engine. These 3 conditions we have to check. This is our case study now. So based on this, we have solved for the case 1, case 2, case 3. Before going there, primarily we are finding the maximum efficiency of the Carnot cycle. So what is the maximum efficiency of the Carnot cycle? We are using the temperature is around 50%. Then we are coming for our case 1, case 2, case 3. So in the case 1 we have found, so this is our case 1. So in the case 1, what is the efficiency is 90.6. So therefore this is a possible reversible heat engine. And coming our case 2, the efficiency was 50, which is same as the Carnot cycle efficiency. So always irreversible cycles efficiency are same. Therefore this is a possible irreversible heat engine. Coming to our case 3 here. So the efficiency is higher than the maximum efficiency. So this is not possible in any cases. So this heat engine operating between these conditions cannot be there. Okay. So this is our case study. Thank you.